All right, hey, everybody, Math 35. Midterms are graded, your scores are up. I don't have them with me. I will have them on Thursday. I just forgot. That's what I do. That's what I do, folks. All right, so let's take a look at what we're doing. We're starting chapter 3. In chapter 3 in general is on polynomial and rational functions. So we should define a polynomial function to start off with. A polynomial function f of degree n and we want n to be a non-negative integer. Like 0 or higher. Comes in the form f of x equals a to the sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot a sub 1 x to the first power plus a sub 0 x to the 0 power. So some examples of different powers. Just something simple like a number. This is a constant function. And the way that shows up as n to the 0 is because I could put x to the 0 power right here. And it's still just 13. X to the 0 equals 1. We could have something glorious. You've seen these are linear functions. Most of what we're doing in 3.1 is on the n equals 2. Quadratic function. I really have no idea why they call these quadratic. Linear, I understand. It's got the word line right in it. These are parabolas, though. Quadratic functions are parabolas. I don't know what the quad part. Why 4? I don't know. I don't fucking get it. Because after that, they start sticking with, well, they start sticking with shapes. at least for the next one. The highest degree or the highest exponent tells me what form it is. This is a cubic function. So I don't know why they don't call it the squared function. I guess squared means just a square. I don't know. So you'll know this is a quartic. And we can go higher. They start getting a little unmanageable. The leading coefficient has a name. Well, that is its name. This is the A sub n term. It's the coefficient on the variable with the highest exponent. And the only requirements on the A sub things is the following. For an nth degree polynomial, I was it wrong in order. The only thing that can't be weird, I cannot have a sub n equals 0. If I do, it's just an n-1 polynomial. Like I can't call this a quadratic if I have a 0 on the x squared. It's that idea. It's still a polynomial, it's just a lower degree. But we can have complex numbers in there. We can have irrational numbers in there, like radicals. We can have a lot of fucked up shit in there. We just don't want the front one to be 0. Okay. Ready for more? Okay. So in this first section, 2.1, we're focusing on quadratic functions. Which comes in the form f of x equals ax squared plus bx plus c, where a does not equal 0. And a can be complex. You know, have like an I in it. It can be pretty crappy. We talked about graphing these before. When we graphed this in 2.7, we had f of x equals a times, we effectively had a times x minus h squared plus k. Where the vertex has a parabola. I'm sorry, where the parabola has a vertex. at HK. And a common way of graphing these is graph the vertex. If A equals 1, this is where we did the left or right 1, up 1, left or right 2, up 2, left or right 3, not up 2, up 4, left or right 3, up 9. And so we could plot more points, draw our parabola. If A does not equal 1, well, it really actually holds true all the time. But if A does not equal 1, it's easier to remember doing it here. We have the same setup. But now, rather than going up 1, 4, or 9, we got to multiply it by A. So we'll go up A, up 4A, and up 9A. We'll look at these examples.
Go. Let's go.
So the question is, if we start with f of x equals ax squared plus bx plus c, how can we get to the form where it's easier to graph? F of x equals a times x minus h squared plus k. Is there any, oh, someone's right. There's a couple ways. One of them is substantially easier than the other, but I'm showing you both ways. They generally offer extra credit for doing it the harder way. All right, so let's just start with an example and teach from there. We'll start with something where a equals 1. You have done this before with a slightly different approach. Complete the square. In the past, we added the constant to the other side and went from there, but I'm going to show you another way. I do not want to touch the left side, but I want to do that complete the square approach, so I'm going to move that -4 over a little bit. So the idea here Dear, oh my God, I'm sounding like some of my fucking international teachers in grad school. Like French and people, they say idea. It says the idea, idea. If I can't touch the left, if I add something to the right. I have to also subtract it. So that I don't change the overall value. So when we completed the square, we would take that. We would divide it by 2 and square it. And what went in parentheses was that value before we squared it. The question is, what do we do with the rest? So if I take the 4 over 2, that's the 4 over 2 is that part right there. Then that's 2 squared equals 4. I needed to add 4 here to complete the square. And since I added 4, I do not want to change the overall value. I have to subtract 4 as well. I want to undo anything I've done. This part all groups up to make that. And whatever's left gets moved to the end. -4 minus 4 is -8. So where is my vertex here? 2, -8. Close.
-2.
-2, -8. Yes. The thing inside is the opposite sign. So completing the square is one approach. And it works even if there's a value in front of it, in front of the x squared. We'll do one of those in a second. The other approach is there is a vertex or quadratic functions of the form f of x equals ax squared plus bx plus c. Have a vertex at -b over 2a, f of -b over 2a. So all you gotta do is find -b over 2a, that gives you your x value, and then you plug it in, and that gives you the y value. We'll do that here. So for f of x equals x squared plus 4x minus 4. My h is this -b over 2a. In this problem, that is -4 over 2 times 1. Which gives me -2. That's some pretty cool shit. Cause then we plug it in. And I get f of -2. -2 squared is 4. Plus 4 times -2 is -8, minus 4. F of -2 equals -8. And I have my vertex at -2, -8, just like we got above. You guys ready to try complete the square on your own? Give these a try. Give this a gander. Is everyone done with that page? Realize that I'm doing a little hasty. Okay. Spring. Big. 6. Big 6. All right, so. I'm going to take that 2x divided by 2 and squared. I'll move that -1 over for a second. So 2 squared is 1, 1 squared is I'm adding 1, so I'm going to subtract 1. Which means my f of x becomes x plus 1 squared minus 2. So we could graph right from it. My vertex is -1, 2. Or 1, -2, I should say. My value in front of the parentheses is a 1. So it's just left, right, 1, up 1. Left, right, 2, up 4. So that's f of x equals x squared plus 2x minus 1, or f of x equals x plus 1 squared minus 2. Either form. If we try the negative b over 2a, b is positive 2, a is 1. So I get h equals -1. And if I plug it in, f of -1, -1 squared plus 2 times -1 minus 1. We clean it up, we see that we get -2. So what changes if a does not equal 1? Remember, a is the value coefficient of x squared. Well, we already talked about how it affects the graphing. How does it affect completing the square? First off, it doesn't change the h equals -b over 2a and k equals f of -b over 2a. Those still stay the same. To complete the square only has a single more step. Has only the slightest of changes. which we will do on the next page. All right, let's take a look at it. It's probably easiest just to show you by example rather than trying to write a paragraph about it. And I'm deliberately making it shitty. So you can see it worked out shitty. So, same process, except we want to factor out the 2. So factor out the A. On the first 2 terms. This is going to give me x squared plus 1/2 x. I'm going to leave a little blank and I'll put the -6 over here. So I know I'm going to have a 2 here. I'm going to have an x plus something here squared. Just getting that pre-prepped. So I take the 1/2. And dividing it by 2 doesn't really work, so maybe multiplying it by 1/2. And I square that. So 1/2 times 1/2 is 1/4. That's the value that goes in here. If I square 1/4, I get 1/16. So I am adding 1/16 inside this parenthesis. Now, when we did it in the last one time, we subtracted 1/16. But on the right-hand side, I have not just added 1/16. I have added 1/16 times that A. 1/16 times 2. Which is really 1/8. So since I've added 1/8, I have to subtract 1/8. If I get a common denominator, I got 6 times 8 would be 48 over 8 minus 1/8. That's this part right here. So I'm really subtracting 49 over 8 at the very end. That looks hella sketch. Hella sus. But we can check it. We're going to do our h equals negative b over 2a. And I get negative 1/4. And if I stick that into the equation. This part isn't gonna be pretty, but it's doable. One-fourth squared is 1/16. And if I multiply by that 2, I get a 1/8 there. So let's get a common denominator with the other stuff. And we'll multiply the 1/4 by 2/2. And the 6 by an 8/8. Got 1/8. I was supposed to stick in -1/4. That should be a negative right there. -2/8. -48/8. I'm gonna keep it fun. I'm gonna give you guys one to do. While I work this out and try to do the completing the square. All right, let's take a look at what you guys got. So I'm going to factor out the fourth. So here I am taking -1 and dividing it by 2. That'll give me 1/2. And I'm squaring it. Which means 1/2 squared is 1/4. So I'm really adding, I've added 4 times 1/4, which is just 1. Which means I have to subtract 1. It's -15 minus 1 is -16. I have a vertex at 1/2 comma -16. So if I wanted to graph it, this could be a pain in the ass to graph, right? Doing the over, well, even with grid lines, going the over 1, up 1, or up 4 is going to be a pain in the ass. So if you want to speed up graphing, there are other things you can do. For example, we can find intercepts. The y-intercept is when x equals 0. Just like for a line. So f of 0 just gives me -15. That's not too bad. Then the other option is doing the x-intercept. The y equals 0. Which is my f of x. This does factor. If you wanted to speed it up, it is 2x plus 3 and 2x minus 5 equals 0. So 2x plus 3 equals 0, or 2x minus 5 equals 0. Well, so you guys did pretty well when you got to this point on the test. So maybe if I'm measuring these in halves, That's 5 halves. And 3 halves. And if you want another point down here, we can use a little bit of symmetry. To get to this red point right here, I went left 1 and up 1. I can see that by how far I moved. I can do that same thing on the right. So I can go right 1 and up 1. That's not right 1, that's right 1/2 or left 1/2. So right 1/2 and up 1. Which is fine, I have these scaled as 1/2. And then makes it a little easier to do this side of it as well. All right, so is everyone done with that? Not necessarily easy, especially when you start working with the fractions. 3.2 is on something called synthetic division. And a couple other little miscellaneous rules that we're gonna throw in. Let's do regular division on something real quick, just to remind you how it works. And then we will shortcut this with synthetic division. So I'm dividing x minus 3 into 4x cubed minus 15x squared plus 11x minus 10. Have we done this semester yet? No, okay. So the way we do synthetic, this is regular division of a polynomial. The way we do it is we see how many times x, the term in front, goes into the first term here. The easiest way to do it is just divide. So 4x cubed divided by x equals 4x squared. That's what I'm going to put up here. And I'm going to take it, and just like with regular division, when you do it by hand, you take this, you multiply it by the thing out front, and you subtract it. So 4x times x is 4x cubed. And 4x squared times negative 3 is negative 15x squared, or negative 12x squared. Then we do subtraction. So we subtract everything in there. And the easiest way to really go about doing it is like move the negative in sign by changing the signs. The 4x cubed minus 4x cubed goes away. Negative 15x squared plus 12x squared is negative 3x squared. And I bring down the rest. And I continue. How many times does my x go into my negative 3x squared? It goes in negative 3x times. So if I do that, negative 3x times x is negative 3x squared. And negative 3x times negative 3 is plus 9x. Again, I'm going to subtract that. When I move that inside, it changes the signs. So negative 3x squared plus 3x squared becomes 0x squared. That goes away. 11x minus 9x is 2x. And I bring down the negative 10. And finally, I do it one last time. I've got a 2x here. I'm dividing it by that x out front, and I get 2. So I'll put a plus 2 here. Do the same process. 2 times x is 2x. 2 times negative 3 is negative 6. When I subtract this, it changes the signs inside if I want to do addition. And I got 0x and then negative 10 plus 6 is 4. This is where I stop. When the thing here is larger or smaller exponent than out here, I stop. I just take this and I add it as a numerator over that denominator we had out front.
It wouldn't be -4.
It would be -4, yes. Good catch. So that's the answer to that. If I divide that by that, I get 4x squared minus 3x plus 2. And then I can just say minus 4 over x minus 3. I'm going to multiply through by x minus 3 right here real quick. If I do that on the left, it just gets rid of the x minus 3 on bottom right. And I am lazy as fuck, so I do not want to multiply the x minus 3 times that 4x squared minus 3x plus 2. But it's pretty easy to multiply by the remainder, right? That is actually pretty handy. what did this, I could say this is, I could say this is like, this is my f of x. I could say this is like x minus h times some other function, maybe q of x. Plus a remainder function, r of x. This works on any polynomial. This is called the division algorithm, if you want to know a name for it. But using it as it is like that isn't all that helpful. But it does have some interesting properties when the remainder is 0, which is where we're heading. But before we do this, this was a pain in the ass to do, right? This division. This is very much a huge, gigantic pain in the ass. So how can I speed up a understory? Let me wait. There is a much faster way. It looks a lot cleaner, and we don't have X's all over the fucking place. We just have numbers. Let's show you. This process is called synthetic division, and we're gonna do the same problem. Since we know the answer already, we can see that it works. What we're going to do is we're going to make a box. And I'm just going to put the coefficients that I have here inside. If any exponent doesn't, if an exponent doesn't show up, put a 0 placeholder there. In this problem, that doesn't happen, but I want to make sure you know it from the beginning. So if this is like my x minus h, x minus 3 is like my x minus h, then h equals 3. That's what I'm going to put out front. So it's kind of like the opposite sign of what you have that you're dividing by. Procedure goes like this. Just bring the first number down. Just comes down. Then we're going to take the thing on the outside and multiply by the number here. So 3 times 4 equals 12. I'm going to put 12 here. And I'm going to add. Negative 15 plus 12 is negative 3. And then I do the same process. 3 times negative 3 is negative 9. I'll put the negative 9 there. Again, add. Or in this case, basically subtract. 11 minus 9 is 2. Finally, I do the 3 times the 2 here. And I get 6, and I'll put that there. And I add those up and I get -4. See what we had before? When we did division? Four and 4, -3 and -3, 2 and 2, -4 and -4. So the way synthetic division works is you just do this division thing. These give you, these are the coefficients of a polynomial 1 degree smaller. We do that here. We started off with x cubed. That was the original. So we drop it down to an x squared. We'll put an x squared with the 4. An x with the -3. An x to the 0 with the 2. And the remainder we have to put over the original thing. And you can see that gets us our 4x squared minus 3x plus 2 minus 4 over x minus 3. Let me give you guys an example to try. Just a second. You guys ready? Let's do f of x equals -3x to the 4th plus 15x cubed minus 50x plus 25. And we want to see what happens if we divide by x minus 4. So just to make sure no one fucks up the box, what number should I put inside the box?
3, 15, 0, -50.
You said 3, it's actually a -3 to start with. There is a 0 there. Good catch. There is no x squared here, right? There's a 0x squared there. It's sneaky, it's hiding. And what number goes out front? 4, the opposite sign of what we see. Okay. Then let's look at Chilling. Bring -3 down, we multiply by 4, we get -12. 15 plus -12 is 3. 4 times 3 is 12. We add those up, we get 12. Um, 48. Add those up, I get -2. And 4 times -2 is -8. And I have 17. Which means that dividing by that value gives me a polynomial of 1 degree smaller, which would take me down to x cubed. And then just plugging in those coefficients. So another way of writing that f of x, I can write it as x minus 4 times -3x cubed plus 3x squared plus 12x minus 2 plus 4. Yeah.
17.
That, where the fuck I got the 4 there? I don't know. You're right, that's 17. Which means that's 17. Thank you. Just off in my own world, just daydreaming, making shit up. Man, just making it up as I go. So, check this out. So this is like what I was saying earlier. This is f of x time or equals x minus h times some function, we don't know what it is, plus r. And if I say this in our case was x minus 4, if I evaluate at f of 4, this one, what happens? Look at that line right there. Just look at the green line. What happens if I stick in 4? What's 4 minus 4? 0. What's 0 times anything? 0. So who gives a shit about the rest of this? It just spits out the answer. Final constant at the end. This is called the remainder theorem. And the way it's worded is if the polynomial is polynomial f of x is divided by they like to use k, I was using h, x minus k, then the remainder equals 2 f of k. That's useful. I've got f of x equals x minus, they use k, so I'll use k here. X minus k times some q of x plus r. And if I plug in k, I get r. What happens if r is 0? There's no remainder now, yes. There's no remainder, so now f of x equals x minus k times q of x. What does that say about x minus k? So I'm gonna push it with a smaller one. Let's do. Let's motivate the idea real quick and see, let you guys see what happens. Let's say f of x equals x squared minus 2x minus 3. And we are going to check x plus 1. So we set up our sky division, our synthetic division. I like calling it sky division because the numbers just kind of float up top. The number that goes here is -1. What does this give me? We started off with a degree of 2. So we write it as the coefficients of a degree that's 1 smaller. And I have no remainder, so I don't need to worry about that. This is just x minus 3. If I follow this format up here, I am writing it with my x minus k, which is x plus 1. My q of x is what remains, x minus 3. And I have no remainder. What are these? They're factors, aren't they? If r equals 0, x minus k is a factor of f of x. That's kind of actually pretty cool. Because when you want to graph this shit, and it's a really big, like, polynomial, if you have this down to all factors and you set it equal to 0, like, let's say it's, change the colors real quick. I've got an x minus k, and I've got an x minus e, and an x minus c, and an x minus b, x minus d, x minus a. This is going to be a pain in the ass to graph, but if I say y equals 0 or f of x, I now have all of my x-intercepts. And my x-intercepts are k, e, c, b, d, and a. So if we can write it and figure out these factors, we've made that graph a whole lot easier by finding those spots. These have a name. These are called the zeros or roots of the polynomial. F of x. Okay, so the zero of a, put it in words, a zero of a polynomial function is a number k such that f of k equals 0. If k is a real number, then k is the x value of the x-intercept. Give you a couple examples, and then I want to walk you through doing one of these synthetic divisions with complex numbers too. So let's just look at some examples. So in the following, are or is k greater than 0? For a, we're going to have f of x equals 2x cubed minus 3x squared minus 18. And we're say k equals 2. If I plug in f of 2, 2 cubed is 8 times 2 is 16. 2 squared is 4 times 3 is 12. Getting negative 14, which is not 0. So K is not a 0. This is worth you trying later on, practicing your synthetic division on. If you do divide by x minus 2, you should get 2x squared plus x plus 2, and then minus 14 over x minus 2 on that one. We had more time in class, I walked through it, but I really want to do that complex one. Next one for you guys to check. F of x equals x to the 4th minus 4x cubed minus 14x squared plus 36x plus 45. K equals negative 3. So check to see if this is a 0 by using the remainder theorem. Plug in K and see if you get 0. What does F of K equal? You should get 0 when you do it. Just be careful with the signs and the exponents because it is a negative value that you're doing. So if I rewrite it as the x minus k times the thing, if you practice your synthetic division, these should be the coefficients you get. You want to try it out later? I want to walk you through a complex one now. Okay, let's take a look at a complex number. So if I do x minus k, this is really x minus 1 minus 3i times q of x plus r. That's what we're really working on here. We're going to do the synthetic division now. So my k is my 1 plus 3i. And I suggest you give yourself some space, especially with complex numbers. And you write the coefficients. You want to have room to work with the complex part. Bringing down the one is easy. And doing the first step here is pretty easy because it's just multiplying regular values. 1 times 1 plus 3i is 1 plus 3i. If I add these two up, I just get 3i. This is where it starts being a little bit of a pain in the ass. So I suggest you do a little bit of work down below on doing that multiplication. And take 3i and multiply by the 1 plus 3i, and I get 3i plus 9i squared. But remember, I squared is -9 or -1. So this becomes 3i minus 9 or -9 plus 3i. All right, so we add here. 6 minus 9 is -3. And I still got the plus 3i. Now this I gotta multiply this out. I got 1 plus 3i times -3 plus 3i. I got -3 plus 9i. Nope, minus 9i. Plus 3i. Plus 9i squared. And we know the 9i squared is -9. Because I squared is -1. If I combine these together, I've got -3 minus 9 is -12. -9i plus 3i is -6i. All right, finally. We subtract or add. I've got 2 minus 6i here. Not a lot of fun, is it? This isn't the most fun you've had, I'm sure. But it is interesting. Whether it's fun or easy, it's a different question. Because this shit matters in stuff like electronics and stuff like that, circuitry. And if the 18i squared, negative 18i squared is just plus 18. So this all adds up to 20. And so this is a root or a 0 of f of x. You just can't graph it. Not on the real number line. It doesn't mean stuff when we start graphing. We'll graph crazy polynomials later. But what it means is we can write f of x, which was originally x to the 4th minus x cubed plus 6x squared plus 14x minus 20. That's what we started with. We can rewrite this as x minus 1 minus 3i times some crazy shit. I got x cubed plus 1 plus 3i x squared plus negative 9 plus 3i x minus 12 minus 6i. So k equals 1 plus 3i is a 0. And the only good thing about complex numbers that are zeros, I don't really want to call them roots, because we tend to call roots anything we graph on the number line. It kind of is. The good thing about it is they fucking come in pairs. We just showed this one as a 0. As we will see this either this week or next week, this guarantees that the complex conjugate is also a 0. That's some cool stuff that we'll do later on now. And that'll be up there anyway. Let's call it a wrap.
So that means that plus 3 that should be a 0.
Say that again.
And then you get 1 plus 3.
We already showed the 1 plus 3i was a 0. That's what we did right here. But now the complex conjugate will also be 1. Which is pretty cool. All right, I will see you guys on, what day is it? Tuesday, on Thursday?